Hi, pre-calculus. We are going to do a lesson that is solving inequalities by testing the sections. Okay, and we're going to do that using a number line. Okay, I feel like we've done this lesson a couple times. In each chapter, we always talk about the inequalities. Okay, and we have to use a number line to figure out where it's greater or less than 0. Okay, so I'm going to take a look at this first example right here. The first thing that we're going to do, of course, is factor. So the numerator is already the quantity x minus 1. The denominator is a difference of squares, x plus 2 times x minus 2. Okay, and then we have greater than or equal to 0. Okay, so I am going to draw a number line, and we're going to put all the critical values on the number line. Critical values are ones that make the numerator or the denominator 0. So I notice here that the numerator would have a 0 at 1. So 1 is a critical point. In the denominator, we have plus and minus 2, positive and negative 2, okay? Except they're in the denominator. We never want the denominator to equal 0. So if you have a critical value from the bottom, okay, we're going to make that be an open circle. It's super important that you put the critical numbers on here and that you put open and closed bubbles. A lot of people don't put those, but I need to see them. If they're from the denominator, we're clearly going to show that this value is not going to be included. Now, what about the numerator? Okay, the numerator, 0, it's okay for the top to be equal to 0. And in this case, I do want to equal 0. I want to. So if the critical value comes from the top, I'm going to look at this sign. Since it says equal, I'm going to fill it in. Okay, and now I'm going to test these sections. Notice I did not put 0 on the number line. That's not a critical value. 0 is allowed into this problem, and it would calculate. All right, you only put the critical values. Now, this problem, okay, says greater than or equal to 0, so we want positives. Okay, and I'm going to test the sections. This first section right here, I'm going to test the value negative 10. I'm going to put it into the inequality over here, and I'm going to see if it gives me a number that is indeed positive. So negative 10 minus 1, that's going to make negative. In the denominator, negative 10 plus 2 makes a negative. Negative 2 minus 2 makes some more negatives. Okay, a negative times a negative here is going to make a positive. And then negative divided by positive makes negative. Okay, we wanted positive. So this section doesn't work. All right, I need to see your testing. The testing could be something as simple as plus and minus signs, but I need to see it. All right, this section right here, I think the easiest number right here would be if we tested a 0. Okay, so in the numerator, 0 minus 1 is negative. 0 plus 2 would be positive. 0 minus 2 is negative. And negative divided by negative makes positive. And that's what we wanted. When we plug values in that are in this section, okay, we get positive. So we're going to color in this section, highlight it. Okay, please show me that it worked by coloring it in. Okay, this next section right here, this is going to be tricky. I have to find a number between 1 and 2. I'm not allowed to plug in 1. And I'm not allowed to plug in 2. If I plug in 1, that makes everything 0. If I plug in 2, it makes it undefined. I'm curious about the numbers in between. I'm going to test the number 1.5. Okay. 1.5 minus 1 would be positive. 1.5 plus some more is positive. 1.5 minus 2, that's going to be just enough to be negative. And this is turning out negative. But we don't want negatives, we want positives. And now we have the last section. Okay, I'm going to test the number 100. Why so big, you say? Sometimes it's easy to think big. 100 minus 1, clearly positive. 100 plus 2 more, positive. 100 take away 2, positive. positive divided by positive makes positive, and we did want positive. So this section, okay, this section is full of answers. All the numbers greater than 2, like 3, 4, 5, 6, 7, are all, okay, they're all going to work. Those numbers work. Okay, so now we have to officially say our answer, and I know a lot of people do like using the interval notation. This first interval right here starts with parentheses -2 and goes to value 1 with brackets. Okay, don't forget your union. Then from parentheses 2 to infinity. Infinities always get the parentheses. Okay. That's how you solve inequalities. There's a rational inequality by testing the sections. Okay, we did this with parabolas. We've done this before. When it starts getting this complicated, it's best to make a number line. Okay, let's go through the steps here. The testing the section steps, okay, there's quite a few of them. The first one is to set the equation equal to 0. Okay, so what that means is get everything to one side and make a 0. You have to be able to say greater than 0 or less than 0. In other words, positive or negative. The second step would be to factor completely. Factor completely, the top and the bottom. Okay, factor completely the numerator and the denominator. Step 3, we're going to put the critical values on the number line. Put the critical values on the number line. The critical values come from the numerator and the denominator. Anything that might make the function 0 or undefined. Something's happening at that point. Number 4, okay, if you have less than or equal to, or you have greater than or equal to, okay, we're going to use a closed bubble. For the zeros that are from the numerator, for zeros from the numerator. Okay, and then we would use, if it is less than or greater than, you would use open bubble for the zeros from the numerator. Okay, so the numerator depends on the sign. Okay, but we always use an open bubble for the zeros from the denominator. Okay, we always use open from the denominator. You don't want the bottom to equal 0. Okay, the denominator gets open, numerator depends on the sign. Okay, and then the last section is the fun one. Okay, step number 6, you test the sections. You test the sections, your parenthesis, 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 parenthesis. Then you look at the problem, okay? Then you look to see if it says greater than or equal or less than or equal to 0. Okay, then you ask yourself, do you want positive or negative? And that's how you test the sections. I'm going to keep these steps here while we do another example. Okay, they're going to come in handy. Keep them close by when we do our practice in class. Number 1, is the equation equal to 0? And it's not. I need to move everything over to the other side. 6x minus 5 minus that fraction 6 over x less than 0. Okay. I'm going to have to make common denominators here. Okay, since these are fractions, let's put 1s right there. And how do you add and subtract fractions? We're going to have to make common denominator of x. He's already got an x. But this first term right here, he needs to get multiplied top and bottom by x. This second fraction needs to get top and bottom multiplied by x. So I now have a common denominator of x. And what's the numerator? 6x squared minus 5x minus 6 is less than 0. Don't forget, to keep writing your 0. Yes, that's important because when we test, I'm going to want to know if it's greater or less. Okay, so set equation equal to 0. Check. I just did that. Factor completely. Okay, let's do that. Let's factor the numerator and the denominator. Let's see. we're going to have to make a 6. Let's try 3x times 2x. And let's try 2 and 3 again. If I put 2 right here and 3 right here, that would make outers of 9, inners of 4. 9 and 4. If this was positive and this was negative, that would make a minus 5. Don't forget my less than 0. Okay. Factor completely, check. Numerator and denominator. Number 3, put the critical values. Okay, so let's get a number line going. The critical values. So we've got 0 from the bottom. That's a critical value. This is negative 2/3. And this critical value is 3/2. Okay. All right, check. Number 4. Okay. From the numerator, I have a less than sign. Less than signs, we're going to put open bubbles on these fractions. Open bubbles. And then x, which gave us 0, always use open bubble for the denominator. Okay, all right, so everything's open. Open because denominator, and then open because less than. Okay, check, check. Oh, it's the fun part, testing the sections. Okay, this problem says that the function has to be less than 0. Not equal to 0, but less. Okay, so we want negatives this time. Let's think of a fun number in this section. This is negative 2/3. I could do negative 1. Sometimes people go really big. It doesn't matter. The first set of parentheses. Negative 3 plus 2. Oh, that's going to be a negative. The second set of parentheses, negative 2 minus 3, that's going to be a negative. And if x is negative, let's see, cancel, cancel. Positive, divide by negative makes negative. Oh, we wanted negative. So this section is a good section. Highlight the arrow too. Okay, all these numbers are going to work. All right, what number is in here? 0. Negative 2/3. How about negative 1/3? All right, this is going to be fun. Negative 1/3 times by 3, that's negative 1 plus 2. That's going to be a positive. 2 times negative minus some more negatives. That's definitely going to be a negative. Negative x, that's going to be a negative. Cancel, cancel. This section came out positive. Does not work. I feel like I need to say something here. Sometimes it could be 2 sections in a row. Sometimes it's 3 in a row. Sometimes it's every other one. Don't make up this weird rule where you do 2 problems and then mathematically you come up with something. Okay, that's not how it works. You have to actually test. There's something happening here. It's critical. Something happens at that point. Okay? A number between 0 and 1.5. I'm going to pick 1. Just try to stay away from the decimals if I can. 3 plus 2 more, that's a positive. 2 minus 3 is a negative. This is coming out negative. Okay, that's a good section. Okay, and the last one, I'm going to test 100. I'm going to test 100. Let's see if people like big numbers. 300 plus 2, positive. 200 minus 3, positive. 100's positive. Is that a good section? No, not a good section. Okay, great testing. I need to see some work. You could just do positive, negative, who cares? Or you could actually put numbers there. Okay, and I need to see highlighting. Now, what's the official answer? This first section right here is from negative infinity up to negative 2/3 parentheses. Union from 0 to 3/2. Those are the 2 sections, okay, where this function is less than 0 under the x-axis. All right, let's do a couple more till you get the hang of it. Solve this one algebraically. Oh, okay, well, it looks like it's already factored. Ooh, maybe that bottom a little bit. Let's see. This numerator right here, this numerator, I'm going to write it as 3 minus x, 3 minus x, and 3 minus x. I'm going to write it 3 times, okay, because it's 3 quantities. And we also have the quantity 2x plus 1. A difference of cubes. Difference of cubes. That's going to be x minus 1. Then we got to sop it up, remember? X times x is x squared. Then we've got 1x. Now we've got 1 minus sign, plus sign, plus sign. Okay, greater than or equal to 0. All right, let's think about the critical values here that are going to go on our number line. Okay, if this is confusing for you, remember, you can always go and solve. You can solve for the x-intercept. 3 minus x is equal to 0. Negative x is equal to negative 3. Then you change. I'm getting a 3. Positive 3. Okay, so that is a critical value. Positive 3, positive 3. I don't have to put it on the number line. He's already there. This one's going to give us negative 1/2. This factor right there gives us positive 1. And what x-intercepts or critical values do I get from that? That's right, there are none, because he's an irreducible quadratic. All right, let's see. Any critical values from the bottom have to get open bubbles. Now, what about the ones from the numerator? They depend on the sign, and since this says less than or equal to, these are going to get closed bubbles. Okay, make sure you're drawing bubbles this time, okay? Open and closed bubbles are super important. All right, I think it's time to start testing the sections, okay? I'm looking at this problem, and we want negatives, okay? All right, first section. Let's see. Let's test negative 100. Why not? Negative 100. Okay. 3 minus negative 100. That's going to be a positive. 3 minus 100, another positive. That's another positive. 200 plus 1 is a positive. Let's see. Down here, I don't think it met. We could test with both of these. Okay, or we could test with this, because this is kind of like its own little factor here. We just have to make sure that we say negative 100 times negative 100 times negative 100. Okay, that's going to work out to be a negative. Positive divided by negative is, oh, hang on, I messed this up. This is negative 200 plus 1. This is a negative sign, guys. And then a negative divided by negative. This is going to make positive. Oh, it didn't work. We want negatives. Okay. Can you tell me what the easiest number would be right here to test? Let's test 0. Easiest number in the world. 3 minus 0 would be positive. 3 minus 0 would be positive, 2 times 0 is 0 plus 1. That would be another positive. Maybe I'll test this right here. 0 times 0 times 0 minus 1. That would be negative. This is working out to be negative, and we wanted negative, so this is a good section. Good section right there. Okay, we're kind of limited on numbers. Let me change colors because it's getting kind of squishy here. The only number I'm thinking without using decimals would be a 2. Let's try 2. Okay. 3 minus 2, that's going to be positive, positive, positive. 2 times 2 is 4 plus 1 more is positive. I'm going to go here. 2 times 2 times 2, that would be 8 minus 1, which is a positive. So this is working out to be positive, and that's not what we wanted. Okay, last one. Maybe we'll just test 5. Okay, you can test any number that's more than 3. 3 minus 5. That's going to be negative. That one's going to be negative, negative. 5 times 2, 10 plus 1 is a positive. I'll go up here again. 5 times 5 times 5. 125 minus 1, positive. Okay, so what is this working out to be here? Now, you can cancel 2 negatives out, and then we have 1 negative left over. It's working out to be negative, and that's what we wanted to know. Where is this function less than 0? Okay, final answer. Survey says brackets, negative 1/2 up to 0. Union, brackets, 3 to infinity. Don't forget to say the official answer after all your hard work. Okay, number 4. Solve algebraically. Okay, I see an inequality sign, and there's a power more than 1 on x. Whenever you have a power, lots of x's, you're going to have to do the steps. Step 1, okay, we have to make everything equal to 0. So I am going to subtract the x, put everything on the left. Okay. Step 2, factor completely. Okay, let's factor. Let's take out an x, and that's x cubed minus 1. Ooh, another difference of cubes. Okay, let's go ahead and factor further. We'll say x minus 1. We'll have to sop it up. X squared, change a Rooney, plus x plus 1. Okay, how does this factor? It doesn't. It doesn't factor. Okay, the critical values from the number line. You can't look at a line that doesn't have factors. It has to be factored. Something times something makes 0. That's what makes it a critical value. This quantity right here, this quadratic, does not give us any. This one right here is going to give us positive 1, and this one's going to give us a 0. Okay. They're all from the numerator, but it says greater than, so I'm going to put some open bubbles. All right, let's go ahead and get testing. This first section right here, I'm going to test negative 1. Okay, now you can put it into either of these lines because they have parentheses. Remember that who cares trick where it's negative times positive, who cares? That works because there's a 0. You have to have parentheses. You can't say negatives plus positives always make negatives. Has to be multiplied. But I think I'm going to use this line right here. This line looks a little smaller to work with. It's got parentheses. So you have to use a line with parentheses for testing. Okay, you have to have multiply for testing. All right, negative x, that's just going to be a negative. And then negative 1 times negative 1 times negative 1 minus 1 more. That's going to make a negative. Okay, so this section is coming out positive. Okay, and what did we want? Oh, we want positive. We want positive, so this is a good section. Okay, middle section right here. I'm going to have to test a fraction. I'll have to test 1/2. The first set of parentheses, okay, so there's 2 sets. The first one's positive. 1/2 times 1/2 times 1/2. That's going to be 1/8. 1/8 minus 1. I'm going to think of 1 as 8 over 8. 1 over 8 minus 8 over 8. That's going to be negative. Negative, who cares? Positive times negative makes negative. That's not a good section. Okay, and then over here, let's test 10. Sometimes numbers with zeros are nice. Okay, right here, this first set of parentheses is going to be positive. 10 times 10 times 10 minus 1 is a positive. And that's what we wanted, so that's a good section. Okay, final answer. Final answer is from negative infinity to 0, union 1 to infinity. Testing the sections. Okay, last one. Oh, we've got another rational function, but we don't have a 0. Okay, so I keep looking back at these steps. They're kind of off the screen. Okay, but this is what we're going through. Set it equal to 0, factor. Okay, let's do that. 4x plus 5 and over x plus 2. So that's a fraction. We're going to subtract 3, and that's greater than or equal to 0. Okay, so this is 3 over 1. So it seems like I'm subtracting fractions. All right, how do you subtract fractions? You're going to have to make common denominators. Okay, these are quantities. So if this denominator has the quantity x plus 2, this denominator needs to get that same quantity. But what you do to the bottom, you're going to have to do to the top. Okay, so now they have common denominators x plus 2. My numerator is 4x plus 5. We have to distribute a negative 3. Okay, star that up. That's a minus to distribute. Negative 3x minus 6. All right, let's go ahead and add our like terms together just to clean this puppy up. 4 minus 3 is 1x minus 1 over x plus 2. Well, this problem got super small. Super small. We want positives. Okay, where's the number line? Critical value from the numerator, what is it? Positive 1. Critical value from the denominator, what is it? Okay, negative 2. Now let's talk about the bubbles. Okay, what kind of bubble should I put a negative 2 since it's from the denominator? Yeah, we'll put an open bubble. The denominator always gets open bubbles. How about the bubble for 1? He came from the numerator, and we look at the sign. What should I put here? Yeah, a closed bubble. Okay, and now it's time to officially test the sections. Okay, let's test a number in this section right here. I'll do negative 5. Negative, so there's only going to be a numerator and a denominator. Negative 5 minus 1, negative 5 plus 2. That came out to be positive. Oh, that's what we wanted. We wanted positives. In this section, what would be the nicest, easiest number? Yeah, 0. I'm going to test 0. 0 minus 1, 0 plus 2. It's working out to be negative. It's not what I wanted. Over here, I'm going to test, I'll test 8. 8 minus 1, positive. 8 plus 2, positive. Hey, we wanted positive. Okay, it's time to officially write our answer. Oops. The answer is going to go from negative infinity to negative 2. Union, brackets, 1 to infinity. Okay, couple things I wanted you to get good at today. Can you algebraically solve an inequality by testing the sections? Okay, I can state my solution in interval notation. I know you can. That's the kind you guys prefer. Okay, great job, pre-calc.